So here's the tester circuit kit of BJT, which will tell us about the BJT if it is NPN or PNP. Furthermore, it will also tell us that its configuration is base. Its configuration is a collector base emitter or emitter base collector. It consists of Arduino, two LEDs, NPN indicator and PNP indicator, one common anode 7 segment which will show 1 if it is emitter base collector, or 2 if it is collector base emitter. And here we will place our BJT such that its annotated side will face towards our Arduino board, so that its left leg will be connected to pin 4, its middle leg will be connected to pin 3, and its right leg will be connected to pin 2. Okay, now move towards the coding part. Here is the code. First, I have introduced many variables. Let me briefly discuss them. Here the pin VP1 is the voltage at pin 1, voltage at pin 2, and voltage at pin 3. These are analog inputs. Okay. Pin 1, pin 2, pin 3 are the left leg, middle leg, and right leg of our BJT. And NPN LED and PNP LED. And these are the A, B, C, D, E, F, G. These are connected to the 7 segment display. And similarly, some variables, voltage 1, voltage 2, etc., which we will discuss later. And this is important. This is the forward bias voltage. It's the voltage drop of forward bias junction of emitter base junction, which is nearly equal to 0.7, but it can be changed, so you can change this. It's the threshold voltage. Moving towards our setup, we have set A, B, C, D, E, F as output, also pin 1, pin 2, pin 3, NPN and PNP LED as output. So at the start, the pin 1, pin 2, pin 3, NPN LEDs and PNP LED will be low. Moving toward our loop section, first we will make the middle pin, pin 2 high, and the other pin, it may be left or may be right, pin low. Okay, in this case it is right pin. We will make, and then we will measure the voltage at the base, voltage 2, and we will display it on serial monitor. Similarly, we will reverse the polarity. That is, we will make pin 2 the middle pin low and pin 3 the right pin high, and then we will note down the voltage of the right pin. So if our BJT is NPN, okay, then this configuration, when we keep the base high and other one is low, the voltage occurring at the base will be less than 5 because it is in forward mode. The base emitter or base collector junction will be in forward mode if it is NPN. And when we reverse the voltage, then the voltage at pin 3 will be exactly equal to 5 volt. Now, what are in our previous case, as the voltage drop is there, so the voltage at base B2 is not exactly equal to 5 volt. It will be less than 5 volt, maybe 5 minus 0.7, which is 4.3 volts or somewhere near. Okay, so by comparing these two voltages, we will get to know if it is NPN or PNP transistor. For example, if voltage 2 is greater than voltage 3, if voltage 3 is greater than voltage 2, then what happens? Then our BJT is NPN. Okay, so we will turn on the NPN LED and PNP LED will be turned off. Now, as we know that BJT is NPN, we will get to know that, or either it is emitter base collector configuration or collector base emitter configuration when seen through the annotated side of BJT. So basically what we will do in this function is we measure the voltage, the forward bias voltage drop of emitter base junction and collector base junction. Okay, So what happens is that the voltage drop of emitter based junction is a little bit higher than the voltage drop of collector based junction. Based on this theory, we will try to annotate that it is EBC or BCE configuration. Once we will get to know that which connection is a base emitter and which is base collector junction. Okay, so first we will make the pin 1 pin 2 high and the pin 3 is low. Okay, then we will attain the voltage V2 of the middle pin and V3 of the other pin, and then we will calculate this difference, name it as difference 1. Similarly, we will reverse the polarity and then we will calculate the voltage at pin number 1 and voltage 2 at pin 2, and then we will calculate its difference and name it as difference 2. If difference 1 is greater than difference 2, then we will print that its configuration is CBE, and we will call the function CBE, which will display 2 on 7 segment. Else, if difference 1 is less than or equal to difference 2, then we will print out that its configuration is EBC. Okay, and we will call the EBC function, which will display 1 on 7 segment. Else if uh, our BJT is PNP. Here we have covered the if voltage 3 is greater than voltage 2. Okay, now if voltage 3 is less than voltage 2, then our BJT is PNP. All the code for BJT, if BJT is equals to PNP, is same as if it is as NPN, but obviously it is inverse of PNP. Okay, inverse of NPN. Okay, so here we will repeat the same procedure. So else, if neither the voltage 1 is greater than voltage 2 or voltage 1 is smaller than voltage 2, then we will just turn off both the LEDs and 7 segment display will also show nothing. So here our while loop is complete. Here the function of EPC, which will display 1 on the common anode 7 segment, and similarly CBE function, which will display 2 on common anode 7 segment, and off 7 segment is it will turn the 7 segment off, it will display nothing. Now our coding part is done. Let's move towards our hardware part.
I have three transistors there. One is NPN EBC, one is NPN CBE, and the other one is PNP CBE. First of all, I will check EBC NPN. So here it is showing EBC. Here it is showing NPN, and one is for EBC. Here one is for EBC. Now second transistor, that is NPN, and it is CBE. NPN and 7 segment is 2, which is CBE. Now the third one, BC557, it's CBE. It's showing PNP and CBE.